So today we're going to be working on how to graph sine and cosine graphs. What we're going to start off in this video is going to be a short presentation of what the graph of y equals sine x and y equals cosine x look like. Eventually our goal is going to be able to graph more complex functions like this one up here, y equals a sine of b times the quantity x minus c plus d. This has got all the transformations in it. Okay, so we're going to come back and kind of talk about transformations and how to help them graph in our second video. So today our focus is really just going to be on what does the graph of the parent functions look like, y equals sine x and y equals cosine x. So we're going to start with y equals sine x. One of the things we should have learned from our first standard is the unit circle, and we should understand that the points along the unit circle are simply an x and a y, where the x is the cosine and the y is the sine. So as I go around the unit circle, all these values in here, 1, square root of 3 over 2, square root of 2 over 2, 1/2, all of those values are cosine values at the different angles. So the cosine of 0 is 1. The cosine of pi over 6 is the square root of 3 over 2, so on and so forth. Okay? So that's some key things that we're going to use here. Like I said, we're going to start with graphing y equals sine x. Okay? So here's our graph. Okay? We're going to attempt to figure out what does the graph of y equals sine x look like. Okay? Alright, so x is going to be our angle, and then the y is going to be the height, or the y coordinate from our unit circle. So let's come back to our unit circle. When the angle is 0, the sine value is 0. So I'm going to have the point 0 for my x and 0 for my y. So let's plot that, 0, 0. Alright, let's see what happens. Well, as I go around the unit circle, and remember we go this direction in a counterclockwise, notice what's happening to the y's. As the angle gets bigger, so as I sweep out a bigger and bigger angle, the y values, which are my sine values, which is what I'm graphing, get larger and larger. I go up to 1/2, and then the square root of 2 over 2, and the square root of 3 over 2. Basically, as I go around this unit circle, I'm going up. The y values are getting higher and higher until I get to an angle of pi over 2, and at pi over 2, the y value is up at 1. That is the highest the sine value gets to. After that, as I keep going around the unit circle, my y values actually get lower and lower. I come back to the x-axis. And eventually at pi, I'm now at a height of 0 again. So I started at a height of 0, I went up to a height of 1 at an angle of pi over 2, and then I came down to 0 at pi. And then what happens? Well, then I start actually going below the x-axis. So my y values are actually all going to be negative here. Okay, and we should have seen some of the symmetry. So this would be bringing this point over. This would be a y value of negative, 1/2, and negative square root of 3 over 2. Okay? And I keep going down, down, down until the lowest point my sine ever becomes is at -1. And that's at 3 pi over 2. And then I'm still negative, but then my graph starts to come back up to a height of 0 again. And then what happens? It just repeats and repeats and repeats and repeats. Okay? So we're going to see that. So what we're going to use is the idea that there are 4 key points. The sine graph starts here, and then at pi over 2 it's up at 1, and then at pi it's back to 0, and at 3 pi over 2 my graph's down at -1. And then at 2 pi, this is also 0, or 2 pi, I'm back to 0 again. So we're going to plot 4 key points. 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So let's see how that looks. So I'm going to use, and I'm going to kind of skip around just a little bit, and you're going to see this idea come into play in the next video. My 4th tick mark, I'm going to make 2 pi. Okay. That is one cycle or one period of my graph. That got me all the way around the unit circle in 2 pi. Alright, then this must be my pi. This is 3 pi over 2, and this was my pi over 2. Alright, so what does my graph look like? Well, we just saw that, back to here, the sine of 0 is 0. So I've got the point 0, 0, and that's already plotted. Next key point, at pi over 2, so at pi over 2, my y value is 1. So I'm going to plot the point pi over 2, and I'm going to give myself a little bit of room, and we'll call that 1 up there. Then my sine graph starts to come back down, and at pi, my y value is 0. So pi, I'm back to 0. 3 pi over 2, I'm now down at negative 1. So 3 pi over 2, there's negative 1 down there. Okay. And then lastly, 2 pi, I'm back to 0 again. So 2 pi, I'm back to 0. And then this would repeat. At the next key spot, another pi over 2, I'd be up. And then I'd be back down. And then I'd be even lower. And what's going to happen is you're going to get this curved graph. It looks like this. And it's going to keep repeating. Come back over here for a minute. If I go this direction, this is where my angles are negative angles. So if I go negative pi over 2, I'd be right down here. This is the same as negative pi over 2. So negative pi over 2, I'm at negative 1. Well, here would be negative pi over 2, so I'd be down at negative 1. Yeah, that makes sense. Graph would come down here, and then I would get up to the midline, and then to a max, back down to a midline, down to a minimum. This graph is just going to keep going and keep cycling and keep repeating over and over and over again. Okay? So, what are some things we need to understand about the graph of y equals sine x? Well, y equals sine x, it started right there on the xy axis, right in the origin. Okay? A sine graph always starts at the midline. Okay, so you want to kind of think about the sine graph starts at a midline. That's where it starts at. And then it goes up to a max, right there, back to the midline, down to a minimum. So it started at the midline, up to a max, midline, minimum, midline, and there's one full cycle. I could copy this picture, this black that I have traced, pick it up and set it down right where I ended, and I would end up getting the whole graph. Okay? So some other key things about sine graph, besides the fact that they start at the midline, they also have a range from negative 1 to 1. So the range is negative 1 to 1. The domain is going to be all reals. Okay. So that's a couple of key things, is that the graph's going to go left and right forever, and that's because of the unit circle. I can keep going around and around and around and around. But the other big thing that you're thinking about is that the range goes down to negative 1 and up to positive 1, and that comes from here on the unit circle. That the sine values, which are your y's, the smallest the y value is negative 1, and the biggest the y value is positive 1. All right, so now we're going to graph cosine. How is that different and how is it the same? Well, cosine is still going around the unit circle, and there's a lot of symmetry and kind of similarities around the unit circle. The difference with cosine is that cosine is talking about the x values. So now at 0, the point should be up at 1. So instead of 0, 0, like we got for sine, the cosine of 0 is 1. So when I come over here, the graph's actually going to start up here. So when I graph y equals cosine x, I'm going to graph them on the same one so you can see some of the similarities between them. When I come this way, now I'm talking about the x's. Well, the x's, this is as far to the right as my graph, the unit circle, ever gets. And we're talking about right and left because we're talking about the x values for cosine. as I go to the left, the x values get smaller. Square root of 3 over 2 is smaller than 1. Square root of 2 over 2 is smaller than 1. 1/2 is smaller. Notice these points are creeping towards the left. And then at pi over 2, my x value is now 0. What does it mean for the graph? Well, we're talking about the values, they're coming towards 0. So at pi over 2, I'm going to be at 0. Well, let's keep going. When I get over to these points, now my x values are all negative. So I'm to the left of the y-axis. Same values as over here, just negative numbers. Well, so I'm going to go left, 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 left. As I come around, I'm going left, 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 and I get to the furthest left at negative 1. So when the angle is pi, so the cosine of pi is equal to negative 1. So at pi, I should be down at negative 1. So notice you're seeing the same shape, it's just starting in a different spot. All right, let's keep going. As I keep going around the unit circle, my x's are still negative, but they're now moving to the right. So I'm going to approach 0. So at 3 pi over 2, I get the point 0. So 3 pi over 2, I'm back up to the midline. So my graph is coming back up. And then finally, when I get over to 2 pi, I now get all the way out to the right, so I get out to 1. So at 2 pi, I should be up at 1. And then I would keep coming. The next one would be down here at the midline. This one would be at a minimum. Back to the midline. Negatives, let's just quickly show you. If I go negative pi over 2, I'd be at 0. So negative pi over 2, which would be right there. I should be at 0, which makes perfect sense. Then I'd be down at the minimum. Back up to the midline. Maximum. Midline. Okay. Notice these two graphs, they look identical to each other, they're just shifted. Okay. So the big thing with the cosine is the cosine starts at a maximum. Okay, so the cosine graph started up here at a maximum, whereas the sine graph started at that midline. The range is the same. It still gets up to negative 1, or down to negative 1 and up to 1. Domain is still, all reals. So again, graphs are identical. They're just the horizontal shift of each other. Okay? So biggest things from graphing these guys, you have to understand, you got to find the 4 key spots. And that's these pi over 2 spots. So it's 0, and then, so let me erase this really quickly. Find all the key spots, the maxes, the mins, and the midlines. If you can find those, then the graph is pretty easy to make. So I want to be thinking about, okay, here's a key point, here's a key point, here's a key point, and here's a key point, and then this would be like 2 pi again. So that would have a couple different points. So you can plot those kind of 4 or 5 points and just keep going around and around and repeating and repeating and repeating and repeating. You're going to get the graph of sine or cosine. Okay. The other big thing you got to remember is that the y value on the unit circle is the sine, and the x value is the cosine. Hopefully that kind of helps get you with like what the parent function looks like. Key thing again, maxes, mins, and midlines, understanding and finding those key spots is all we really are expecting you to do in order to sketch the graph. Next video I'm going to show you is how to do some of the transformation graphs and how to find those.